1966. If you were a Harvard student with access to MIT's computer system, you could chat with what looked like a therapist. It would ask thoughtful questions, reflect your feelings back, and seem to really care. It was 200 lines of code, none of which understood a single word you typed. Some users got attached. The lead researcher's own secretary, who knew exactly how it worked, asked him to leave the room so she could talk to it privately. This is the story of the 30 years when the field tried to build understanding by writing rules. Some of it worked, none of it scaled. Last episode, Chomsky won the 1957 argument. For 30 years after that, statistical NLP was unfashionable. If you wanted to build a working language system, you wrote rules. Lots of them, by hand, in Lisp usually. And it worked. Sort of. Better than the statisticians wanted to admit. Worse than the rationalists hoped. This video is the story of two of the most famous rule-based systems, ELIZA and SHRDLU, and why both eventually hit the same wall. Today's 3 beats. First, ELIZA, 1966, the chatbot that fooled everyone with 200 lines of code. Second, SHRDLU, 1971, the system that actually understood in a tiny world of colored blocks. Third, why every rule-based system hit the same wall, and which ones are still running today. MIT, 1966. A computer scientist named Joseph Weizenbaum builds a 200-line program called ELIZA. The most famous mode runs a script called Doctor, a parody of a Rogerian psychotherapist, the kind that mostly asks you to elaborate on what you just said. Here is the famous opening. User, men are all alike. ELIZA, in what way? User, they are always bugging us about something or other. ELIZA, can you think of a specific example? User, well, my boyfriend made me come here. ELIZA, your boyfriend made you come here. And on it goes. The rules are absurdly simple. If the user says something, reflect it back as a question. If they mention mother, respond with something about family. There is no model of meaning, no memory across sessions, no understanding, just pattern matching plus a stack of templates. But users anthropomorphized it instantly. The researcher's own secretary, who had watched him write the program line by line, would ask him to leave the room so she could talk to Doctor privately. He spent the rest of his career terrified by what he had accidentally proven about humans. 5 years later, a PhD student at MIT finishes his thesis. The thesis is a 6,000-line Lisp program called SHRDLU. It is the opposite of ELIZA in every way. ELIZA simulated understanding. SHRDLU actually had some. SHRDLU operates a simulated world of colored blocks on a table. You can have a real conversation with it. User, pick up the big red block. SHRDLU, okay. User, what does the box contain? SHRDLU, the blue pyramid and the blue block. User, what is the pyramid supported by? SHRDLU, the box. It understands. It has memory. It can answer questions about what it has done. But here is the catch. SHRDLU understands one thing. Its world of about 50 objects and 30 actions. The semantics is hand-coded for that domain. To extend it to a second domain, say, kitchen utensils, you rewrite the whole program. Its creator later called SHRDLU a beautiful demo with no path to general intelligence. Both systems hit the same wall. To handle the real world, you need rules for every concept, every edge case, every interaction between rules. The cost of writing them grows faster than the coverage you gain. By 1980, the field had a name for this: the knowledge acquisition bottleneck. A rule-based system gets better and slower as you add rules. After a few hundred rules, the rules contradict each other. After a few thousand, no human can debug it anymore. Expert systems in the 1980s tried to industrialize this. XCON at Digital Equipment Corporation configured VAX computer orders. MYCIN diagnosed bacterial infections. Both had real commercial success. Both collapsed by 1990. For exactly this reason, maintenance cost outpaced the value delivered. But here is the surprise. The rule-based era never fully ended. Microsoft Word's grammar checker is still mostly rules. Most enterprise compliance systems are rules. SHRDLUs. Descendants live in modern robotics. Every grass planter uses the same formal world model. ELIZAs. Descendants live in customer service routing. Every press 1 for billing tree is ELIZA wearing a suit. 3 takeaways before the quiz. 1. ELIZA, 1966. Pattern matching templates with zero understanding. People anthropomorphized it anyway. Lesson about us, not it. 2. SHRDLU, 1971. Genuine understanding inside a block's world. Hand-coded semantics. No path out of the toy domain. 3. Rules died as a general approach. They live in every constrained domain. Grammar checkers, compliance systems, robotics, voice menus. Quiz 1. Who built ELIZA? A Terry Winograd, B. Marvin Minsky, C. Joseph Weizenbaum, or D. John McCarthy? C. Joseph Weizenbaum at MIT in 1966. Winograd built SHRDLU. Minsky was at the same lab but worked on other things. McCarthy named AI. Quiz 2. What world did SHRDLU operate in? A medical diagnosis, B. machine translation, C. a simulated world of colored blocks, or D. chess? C. Colored blocks on a table. About 50 objects and 30 actions. Real understanding inside that world. Zero ability to generalize beyond it. Last quiz. What is the knowledge acquisition bottleneck? A. Rules contradict each other and the maintenance cost outgrows coverage. B. 1980s hardware was too slow. C. Paper was too expensive. Or D. Linguists refuse to write rules. A. Rules contradict each other. The maintenance cost outgrows coverage, and no human can debug a large rule base. The fundamental reason every rule-based system eventually hit the wall. Back to the puzzle. ELIZA shows behavior without understanding. SHRDLU shows understanding without scale. The 1980s spent a decade trying to bridge that gap. They didn't. By 1990, a quiet group at IBM was about to try the opposite approach and beat everyone. Next time, 1993, the IBM team that decided to stop writing rules and just count words. The Statistical Revolution, the paper that quietly killed rule-based machine translation. Hit subscribe if you want it the day it drops.